Hey there everyone, my name is Kenny and welcome to our 5-minute in-depth video for Team Laniakea. So before we get started, I would just like to introduce you to our team first. Our team is a little on the large side, but putting stuff in space is harder than we thought, so we're always looking for more help. Our team is split into different subsystems, and each subsystem is responsible for different components on board the satellite. We will try our best to go over as much as we can in the next 5 minutes, so with that being said, let's get started.
Hi, my name is Jessa Lamas and I am part of the Structures and Mechanisms subsystem. This subsystem encompasses all the mechanical components in the satellite. Primarily, we focus on the structure, and currently we are mainly working on the antenna portion. The pictures on the bottom left shows the CAD model and the 3D printout of the satellite. The pictures on the right shows the PCB of the antenna and the antenna deployment test.
Hi, my name is Nagiro and I'll be presenting for the thermal control system. So for our subsystem, our main goal is to maintain the operational temperature of each of the components within a certain temperature range. And as you can see on the table here is a list of all of our components and their operational temperatures. And as you can see, the battery and the Neuro Compute Stick 2 has the most sensitive temperature ranges. And on the left here is just a simple thermal desktop model that we have.
Attitude Determination and Control Systems, or ADCS for short, is primarily responsible for the detumbling of the CubeSat, while at the same time determining its precise position. ADCS will utilize our written codes with the corresponding sun gyroscope and magnetometer sensors to determine its orientation. Next, the attitude actuators generate external torque along the X, Y, and Z axis to compensate in the correct directions to adequately allow for control and stabilization. So far this semester, we have been primarily working on creating Python language-based codes to implement into our system.
My name is Sebastian, and I am a new member of the EPS team. Our goal is to research, design, and implement an electrical power system model that generates, stores, and supplies power to the CubeSat. Our system consists of solar panels, solar cells, the battery board, batteries, and the power distribution unit. Since most designs were solidified last semester, we are currently in the process of ordering and fabricating all necessary boards. So far, we have fabricated 3 battery boards and plan to assemble the rest as our parts come in.
Hello, I'm Ethan, and I will be talking about the onboard computer subsystem. The OBC subsystem utilizes Cosmos, a flight software developed by HSFL that is responsible for all the operations of the satellite. Using Cosmos, we program different agents, such as Agent Temp, Agent Switch, and Agent Camera. We are currently attempting to fabricate 6 OBCs by the end of the semester.
I'm Kenton and will be introducing the payload subsystem. The payload subsystem plans to take an image of Hawaii using an onboard camera, Cosmos, and artificial intelligence. The camera we'll be using is the Caspa VL, and the Avera Firestorm will be used to control it. AI will be used to autonomously find Hawaii and take pictures using an Intel Neuro Compute Stick. We also plan to transmit the image over comms and ground station.
Hi, I'm Adam, and I'll be talking about the communications subsystem. This subsystem deals with communications between the satellite and the ground station on Earth. Our satellite will use a software-defined radio, the Hope RFM98, to transmit and receive data. We'll use SatNogs, an open-source satellite network software, to operate the ground station. SatNogs uses FSK modulation, so we're currently working to change the Hope RF radio from LoRa to FSK.
Hey there guys, it's Kenny again, and if you've made it this far, we really want to thank you for your interest in our project. If you would like to learn more about our project or our team, please feel free to contact Sean, he's the project manager for our team, or me, I'm one of the team's systems engineers, and we'd be more than happy to answer any of your questions. With that being said, have a good one and take it easy.